Beneath the infinite expanse of the night sky, a quiet mystery lingers, billions of stars scattered like shimmering jewels across a vast cosmic ocean, each one potentially orbited by worlds teeming with possibilities. It is a universe so vast, so boundless, that it defies the limits of our imagination. As we gaze upward, we are not only captivated by its beauty, but drawn into its profound enigma. With countless galaxies stretching beyond what we can observe, billions upon billions of planets spinning in the dance of creation, one question softly echoes through the silence: where is everybody else? Could it be that in this immense, breathtaking expanse of the universe, we are the only ones here? Or is the truth of our solitude far more complex? Tonight, as we journey through the stars, we'll uncover the puzzle that has intrigued scientists, philosophers, and dreamers for generations: the Fermi Paradox. How is it that in a cosmos brimming with potential for life, we have yet to see, hear, or encounter another civilization? So, settle in as we explore the mysteries of existence, the secrets of the universe, and the question that lies at the very heart of it all. And before we begin, let us know in the comments where you're joining us from and what time it is there, because under this celestial canopy, we're all connected. Now, turning to the infinite universe, let us step back and truly consider the sheer magnitude of what surrounds us. Imagine, if you can, billions of galaxies scattered across an unfathomable expanse, each one a cosmic city containing billions of stars. Around these stars orbit countless planets, some barren and desolate, others perhaps bursting with the ingredients for life. And yet, as vast and overwhelming as this may seem, it is just the beginning of what we call the observable universe, a fraction of the full cosmos that we can detect with our telescopes and instruments. Beyond this boundary lies the unknown, realms hidden by the limits of physics and time, where the light of distant stars has not yet reached us. Every corner of this incomprehensible expanse brims with potential, each star system a possible host for life, each galaxy a cradle for civilizations. With so many opportunities for life to arise, the odds seem almost impossible to ignore. Somewhere out there, perhaps life has already taken hold, evolved, and thrived. Perhaps entire worlds are alive with their own forms of consciousness, shaped by the unique conditions of their home planets. The possibilities are as boundless as the universe itself, reminding us of how little we truly know and how much there is yet to discover. But with this awe-inspiring realization comes an equally profound question. Why, in such a seemingly infinite expanse, have we yet to find evidence of any life beyond our own? This is the heart of the enigma, a silence that grows louder the more we learn. Moving forward, we will delve into the tools and ideas humanity has devised to better understand this mystery, starting with a fascinating equation designed to estimate the likelihood of extraterrestrial civilizations. Moving forward, we arrive at the Drake equation, a fascinating mathematical tool that has become a cornerstone in the quest to understand the possibility of alien civilizations. Proposed by the astrophysicist Frank Drake in the early 1960s, this equation attempts to estimate the number of advanced civilizations in our own galaxy, the Milky Way, that might be capable of communication. At first glance, the equation might seem intimidating, but its essence lies in breaking down the question of life into smaller, more manageable pieces. It considers several key factors, starting with the rate at which stars form in our galaxy. Each star represents a potential system where life could emerge. Next, it examines how many of those stars host planets, particularly those that are within a habitable zone where conditions like liquid water might exist. From there, the equation factors in the proportion of these planets where life actually begins and evolves, and further, the fraction of these planets where intelligent life develops, capable of understanding and creating technology. Lastly, it considers the likelihood of these civilizations being willing or able to communicate, and the length of time they might do so before fading from existence. The beauty of the Drake equation lies not in providing a definitive answer, but in sparking a structured way of thinking about the vastness of this question. It invites scientists to gather better data, refine each variable, and imagine worlds far beyond our own, even though the numbers we input are still largely based on speculation and limited evidence. The equation inspires hope. It suggests that even if just a tiny fraction of stars meets the conditions necessary for life, there could still be countless civilizations scattered across the Milky Way. It is both a scientific and philosophical gateway to wonder, urging humanity to keep looking, keep searching, and keep asking questions about our place in the universe. With this in mind, we now turn our attention to the planets themselves, those distant worlds that may hold the key to answering whether we are truly alone. Now turning to the fascinating world of exoplanets, we explore these distant celestial bodies that orbit stars beyond our own sun. The discovery of exoplanets has revolutionized our understanding of the cosmos, unveiling a vast array of worlds, each with its own unique story. Scientists identify potentially habitable exoplanets by focusing on the Goldilocks zone, a narrow range of distances from a star where conditions might be just right for liquid water to exist, a critical ingredient for life as we understand it. This region is neither too hot nor too cold, allowing for the possibility of an environment suitable for life to develop and thrive. Among the most exciting discoveries is Kepler 452b, often referred to as Earth's cousin. This world, located about 1,400 light-years away, orbits within the habitable zone of a star similar to our Sun. Its size and position suggest it might have Earth-like conditions, sparking endless curiosity about what we might find there. And Kepler 452b is just one example. Through missions like the Kepler Space Telescope and more recently the groundbreaking work of the James Webb Space Telescope, thousands of exoplanets have been identified, some with intriguing characteristics that hint at the potential for life. From rocky planets with atmospheres to those with oceans beneath icy surfaces, the variety is staggering. Each discovery adds a piece to the puzzle, pushing us closer to answering the age-old question, are we alone? As we continue to refine our techniques and expand our search, these distant worlds offer a tantalizing glimpse into what might be possible, igniting both scientific curiosity and a profound sense of wonder. With exoplanets painting a canvas of infinite potential, we next confront a cosmic mystery that remains unanswered, the profound silence that echoes through the vastness of space. Now, turning to the profound mystery known as the Great Silence, we are met with a question that lingers in the vastness of space. If the universe is so vast, filled with billions of galaxies, stars, and planets, why have we not yet heard from or encountered alien civilizations? Despite all the possibilities suggested by the discovery of exoplanets and the sheer number of stars with potential habitable zones, the cosmos remains eerily quiet. Radio waves, light signals, even the faintest whispers of a message, none have reached us, leaving a void where we hoped to find connection. This silence grows more curious when we consider the age of the universe, stretching over 13 billion years, giving plenty of time for intelligent life to emerge and expand. If civilizations had developed elsewhere, wouldn't we see evidence of their existence by now? Perhaps a signal, a footprint, or some sign of cosmic engineering. Yet the stillness persists. This absence of contact in the face of what seems to be limitless opportunity is the very heart of the Fermi Paradox. It is a silence that speaks louder than words, challenging us to question and explore. What does it mean for us? What does it say about life itself in the universe? As we delve deeper into this enigma, we begin to uncover possible explanations that range from the comforting to the unsettling, each painting its own picture of our place in the cosmos. Now, turning to the origins of the Fermi Paradox, we find ourselves back in the year 1950, during a seemingly ordinary lunch conversation at the Los Alamos National Laboratory. It was here that physicist Enrico Fermi posed a deceptively simple yet profoundly thought-provoking question. Where is everybody? The context of this query arose as Fermi and his colleagues discussed the possibility of extraterrestrial life, a topic inspired by growing scientific curiosity about the universe. At the heart of Fermi's question lay a bewildering contradiction. Given the vast age and unimaginable scale of the universe, coupled with the high probability of habitable planets, why have we not seen any evidence of intelligent alien life? Surely, if advanced civilizations existed, they would have had ample time to explore, colonize, or at least send signals throughout the galaxy. This single question ignited decades of scientific inquiry, philosophical debate, and imaginative speculation. evolving into what we now understand as the Fermi Paradox. It challenged researchers to reconcile the mathematical likelihood of extraterrestrial civilizations with the stark absence of any observable evidence. Fermi's question was not merely rhetorical, it underscored a fundamental puzzle about our place in the cosmos, a puzzle that continues to intrigue and perplex scientists, philosophers, and dreamers alike. From this moment of intellectual curiosity, a cascade of theories and hypotheses emerged, each attempting to explain why the universe, so rich in potential, appears so hauntingly silent. Now turning to the zoo hypothesis, we delve into one of the more fascinating explanations for the Fermi paradox. This idea suggests that advanced alien civilizations may be deliberately avoiding contact with humanity, treating us as inhabitants of a cosmic wildlife reserve. Much like how we observe animals in protected habitats without interfering in their natural behavior, extraterrestrial civilizations might have chosen a policy of non-intervention to allow humanity to evolve and progress on its own. This raises intriguing questions about their potential motives. Could they see us as too primitive or unready for interaction? Perhaps they believe their presence would disrupt the natural trajectory of human development, altering our culture, technology, or societal structures in unforeseen ways. Some theorists even speculate that these civilizations might have ethical codes or rules that prevent them from meddling in the affairs of less advanced species, akin to a universal prime directive. If this is the case, they might be studying us from afar, monitoring our progress while remaining hidden, much like distant observers in a vast and silent cosmic zoo. Such a scenario paints an extraordinary picture of the universe, one where intelligent life may exist in abundance but chooses to remain quietly in the shadows, watching, waiting, and perhaps deciding when, or if, they will ever make themselves known. This notion invites further reflection on how we, as humans, would approach contact with less advanced species on other planets if ever faced with that responsibility. With this thought in mind, we are left to wonder whether the silence of the cosmos is not an absence, but a deliberate and profound restraint on the part of civilizations far older and wiser than we can imagine. Moving forward, we enter the realm of the rare Earth hypothesis, a perspective that proposes Earth-like planets capable of hosting complex life might be extraordinarily scarce across the vastness of the universe. Unlike the optimistic view that life could be widespread among the stars, this hypothesis narrows the focus to the unique and precise conditions that made life's emergence possible on Earth. Consider, for instance, our planet's stable orbit around a relatively calm star, providing consistent energy without the chaos of frequent solar flares or destructive radiation. Earth resides in what scientists often call the Goldilocks zone, a region neither too hot nor too cold, where liquid water, a fundamental ingredient for life, can exist. But the story does not end there. Our planet benefits from a magnetic field, a protective shield generated by its molten core, which deflects harmful solar winds and cosmic radiation. Without it, Earth's atmosphere could have been stripped away long ago, as is believed to have happened on Mars. Equally critical is the presence of the Moon. Unlike the smaller moons orbiting other planets, Earth's moon is unusually large in comparison to our planet. It plays a vital role in stabilizing Earth's axial tilt, which regulates our climate over long periods. Without this stabilization, our planet might experience extreme shifts in weather, making the development of complex life far more unpredictable, if not impossible. Add to this the rarity of a planet with tectonic activity that recycles carbon and other essential elements, and it becomes clear why Earth might be an exceptional case. These interconnected factors, working in just the right combination, form the basis of the rare Earth hypothesis. It challenges us to ponder whether intelligent life is not common, but a precious anomaly in the cosmic tapestry, shaped by an intricate balance of conditions unique to our corner of the universe. Such an idea shifts the narrative from the abundance of life to its fragility, leaving us to wonder just how many stars out there might host planets capable of replicating this delicate recipe. With the next phase of the journey in sight, we now explore the concept of the Great Filter, one of the most thought-provoking ideas in the search for alien civilizations. The Great Filter suggests that somewhere along the path from simple life to intelligent, spacefaring beings, there exists an obstacle so immense that very few, if any, civilizations manage to overcome it. This filter could lie in our distant past or loom in our future, shaping two profoundly different interpretations of our existence. If the Great Filter is behind us, it means that the emergence of intelligent life on Earth was an extraordinarily rare event. Perhaps the leap from simple microbial life to complex, multicellular organisms was an exceedingly improbable step, or maybe the unlikely combination of events that allowed intelligent beings to evolve, like mass extinctions clearing the way for new species or the precise environmental factors discussed in the rare Earth hypothesis, has already gifted us a unique place in the cosmos. In this case, humanity's existence would represent a triumph over the odds, and the silence of the universe might indicate that most other life forms never made it this far. However, if the Great Filter lies ahead of us, the implications are sobering. It could mean that technological civilizations like ours inevitably encounter barriers to their survival, self-inflicted or external. Consider the dangers of advanced technologies such as nuclear weapons, unchecked climate change, or artificial intelligence spiraling beyond control, leading to catastrophic outcomes. Or the filter could be something cosmic, like asteroid impacts, supernova, or other events that wipe out civilizations before they can spread across the stars. The possibility of a future great filter poses a fundamental question. Will humanity's ingenuity allow us to avoid these existential threats, or are we destined to face the same fate as countless civilizations that might have come before us? This duality makes the great filter concept both haunting and humbling, urging us to reflect on the fragility of our existence and the steps we must take to secure our future. And so, as we ponder what lies ahead, we must also wonder, what does the silence of the cosmos say about where we stand on this journey? As the next challenge unfolds, we examine the fragile balance that defines the lifespan of technological civilizations. Imagine a society like ours, reaching incredible heights of innovation, harnessing energy, exploring the cosmos, and fundamentally transforming its planet. Yet, with such advancements comes a profound vulnerability. Advanced technology, while a source of progress, also introduces risks that could shorten the lifespan of a civilization. Consider the dual-edged nature of nuclear technology. On one hand, it provides energy and scientific breakthroughs. On the other, it carries the potential for catastrophic destruction through war. Similarly, environmental degradation, fueled by industrial progress, could create irreversible damage to a planet's ecosystems, pushing it beyond the point of recovery. And then there's artificial intelligence. While it holds immense promise for solving some of humanity's greatest challenges, unchecked development could lead to unintended consequences, where systems surpass human control and act in ways that threaten their creators. What if these very advancements, hailed as milestones of progress, become the seeds of downfall? The silence of the universe might be a testament to this possibility, civilizations reaching a pivotal moment of technological growth, only to succumb to the dangers they unwittingly unleashed. This raises a poignant question. Can humanity learn from its own trajectory before it's too late? As we stand at the edge of tremendous technological capability, our choices now could determine whether we become a civilization that thrives for millennia or one whose brilliance is extinguished prematurely. Reflecting on this idea, we are reminded of both the immense responsibility we bear and the fragile nature of intelligent life. By examining these potential pitfalls, we might uncover the wisdom needed to avoid them, creating a legacy that endures. Yet, as we ponder these risks, another question lingers. Could alien civilizations have faced and failed these very same challenges, leaving the cosmos eerily quiet? Now, turning to the fascinating idea of invisibility, we explore the possibility that alien civilizations might exist, hidden in plain sight, beyond the reach of our current understanding. Imagine a society so advanced that its technology surpasses anything we can comprehend. Such civilizations could employ stealth systems far beyond our detection capabilities, effectively cloaking themselves from observation. Just as we use camouflage to blend into natural surroundings, an alien civilization might manipulate energy, light, or other physical properties to remain undetectable. Then there is the concept of dimensions. Our perception is bound to the dimensions we experience: length, width, height, and time. But what if these civilizations exist in higher or alternate dimensions, ones imperceptible to our senses and instruments? Physicists have long theorized about the existence of such dimensions, and if an alien society operates within them, we may be unable to observe their presence, much like a two-dimensional being unable to grasp the concept of a three-dimensional world. Additionally, consider the possibility that these civilizations are so different from our own that we simply do not recognize the signs of their existence. Their forms of communication, movement, or even physical makeup might be entirely alien to anything we expect or can perceive with our current tools. What if their signals are embedded in the universe in ways we have yet to understand? Perhaps they communicate through methods that bypass our electromagnetic spectrum entirely, making their messages indistinguishable from the cosmic background noise. These ideas push the boundaries of our understanding and challenge us to consider the limitations of human perception and technology. As we refine our tools and expand our knowledge, might we one day unlock the ability to observe what is now invisible? This notion opens the door to profound possibilities and reminds us that the answers to the Fermi Paradox might lie just beyond the veil of what we can see or comprehend today. Moving forward, let us delve into the vast distances that define our cosmos, an almost incomprehensible expanse that separates stars, galaxies, and potentially alien civilizations. To truly grasp the challenge, consider that even within our own galaxy, the Milky Way, distances are measured in light years, the distance light travels in an entire year. Light, the fastest entity in the universe, covers roughly 6 trillion miles in that time. Yet, even at this staggering speed, traveling from one side of our galaxy to the other would take over 100,000 years. This immense scale becomes even more daunting when contemplating communication or travel across intergalactic distances, where billions of light years stretch between galaxies. Adding to this challenge is a fundamental rule of physics: the speed of light is the ultimate speed limit. No matter how advanced a civilization might be, traveling faster than light, according to our current understanding, is impossible. This limitation creates a significant barrier not only for us but potentially for alien civilizations as well. Imagine sending a signal to a planet 20 light years away. Even if the message is received and replied to instantly, it would still take 40 years to hear back. This delay is a stark reminder of the barriers posed by cosmic distances. Now think about traveling those distances. Even the fastest spacecraft humanity has ever created would take tens of thousands of years just to reach the nearest stars. If alien civilizations face similar constraints, their ability or desire to reach us might be hindered by the sheer impracticality of crossing such vast expanses. These distances remind us not only of the enormity of the universe, but also of the profound isolation it imposes. Could this vastness itself be one of the answers to the Fermi Paradox? Could we and other civilizations simply be ships passing in the infinite night, separated by the immense breadth of space and the limits of time? As we continue to look to the stars, this daunting reality shapes our understanding of the challenges of finding evidence of extraterrestrial life. As the next challenge unfolds, let us explore the dark forest theory, a chilling proposition that adds a layer of mystery and caution to the Fermi paradox. Imagine the universe as a vast, dark forest where countless creatures, civilizations in this case, dwell in silence, each carefully avoiding detection. The theory suggests that advanced civilizations, aware of the potential dangers of revealing their presence, might choose to remain hidden. The rationale is simple yet unsettling. In a universe where resources are finite and intentions are unknown, making your existence known could invite catastrophic consequences. Just as a hunter in a dark forest would tread quietly to avoid predators, civilizations might similarly act to protect themselves from unknown threats. This theory emerges from the idea that not all civilizations may be benevolent. If even one advanced society out there harbors hostile intentions, the risk of broadcasting your presence could be too great to take. The chilling effect of this possibility could lead to a galaxy-wide silence, where even the most advanced beings refrain from signaling their existence. Consider humanity's own efforts to send messages into space, like the Golden Record or radio signals. Under the lens of the dark forest theory, such attempts could be seen as bold, even reckless, gestures, akin to shouting into a forest where danger may be lurking. This perspective offers a sobering explanation for why we might not have detected alien life. Perhaps they are out there, watching, listening, but intentionally remaining unseen. The dark forest theory forces us to confront the idea that silence might not mean absence. Instead, it could signify caution, a strategic decision to prioritize survival over communication. As we ponder this eerie possibility, we are reminded of the delicate balance between curiosity and caution in our search for extraterrestrial intelligence. Could our cosmic neighbors be cloaked in silence, each waiting for others to make the first move? This profound idea adds a haunting dimension to the Fermi Paradox, challenging us to think deeply about the risks and rewards of reaching out into the unknown. Now turning to the possibility of alien life taking simpler forms, let us delve into the intriguing concept of alien microbial life. While the idea of advanced civilizations captures our imagination, the universe may also host life that is far more humble yet equally profound. Microbial life, consisting of microscopic organisms, could be widespread across the cosmos. Evidence supporting this possibility lies close to home. Martian meteorites, for instance, have been found on Earth with intriguing chemical structures that some scientists suggest might hint at ancient microbial life on Mars. Similarly, moons like Europa and Enceladus, orbiting Jupiter and Saturn respectively, offer compelling clues. Beneath their icy surfaces lie vast subsurface oceans, kept liquid by geothermal activity. These environments, rich in water and essential chemicals, are considered prime candidates for harboring microbial life. On Earth, we find extremophiles, microorganisms that thrive in extreme conditions such as boiling hydrothermal vents, acidic hot springs, or under immense pressure in oceanic trenches. If life can adapt to such conditions here, it raises the question: could alien microbes survive in the harsh but intriguing environments of far-off worlds? The discovery of alien microbial life, however simple, would hold groundbreaking significance. It could teach us about the origins of life, the diversity of biological forms, and the potential for life to arise under conditions vastly different from those on Earth. Such findings would not only expand our understanding of biology, but also fuel hope for the existence of more complex life forms elsewhere in the universe. As we turn our attention to the small and unseen, we are reminded that even the simplest forms of life could hold answers to some of the universe's most profound mysteries. Moving forward, let us explore the fascinating concept of the Kardashev scale, a system designed to classify civilizations based on their energy consumption and technological advancement. This scale, proposed by the Soviet astronomer Nikolai Kardashev, provides a framework for imagining the possible stages of a civilization's growth and its ability to harness energy. It is divided into three main types. A Type 1 civilization, referred to as a planetary civilization, is capable of utilizing all the energy resources available on its home planet. This includes harnessing energy from the sun, wind, water, and geothermal sources in a highly efficient and advanced manner. In contrast, humanity today is not yet a Type 1 civilization, as we still rely on limited and inefficient energy systems. A Type 2 civilization, often called a stellar civilization, would have the technological capability to harness the energy of its entire star. One famous theoretical example of this is the Dyson sphere, a megastructure proposed by physicist Freeman Dyson, which would completely encompass a star to capture and utilize its radiant energy. Such a civilization would possess extraordinary engineering and technological prowess, enabling it to build structures on an astronomical scale. Finally, a Type 3 civilization, known as a galactic civilization, would represent the pinnacle of energy mastery, capable of utilizing the energy output of an entire galaxy. Such a civilization might manipulate stars, rearrange solar systems, or even create monumental cosmic structures beyond our comprehension. These civilizations would likely appear godlike to us, possessing abilities that might seem indistinguishable from magic. While humanity is currently far from achieving even Type 1 status, the Kardashev scale inspires speculation about hyper-advanced alien civilizations that may already occupy these upper tiers. If such civilizations exist, their activities could be imperceptible to us, hidden in phenomena we cannot yet understand or detect. Considering the possibilities offered by the Kardashev scale, one is left in awe at the sheer scope of what intelligent life might achieve in the vast expanse of the universe. Now turning to the intriguing idea of non-carbon-based life forms, we find ourselves questioning the very foundation of what constitutes life. On Earth, all known life forms rely on carbon, a versatile element capable of forming complex molecules essential for biological processes. However, in the vastness of the universe, could life emerge from entirely different building blocks? One of the most commonly theorized alternatives is silicon-based life. Silicon, like carbon, can form complex molecular structures and is abundant in many environments. Scientists have speculated that silicon-based organisms might thrive in extremely high-temperature environments, such as the surface of a lava-covered planet, where carbon-based life would be utterly incapable of surviving. Beyond silicon, there is the possibility of life forms arising from even more exotic biochemistries, perhaps utilizing elements like ammonia or methane as solvents instead of water. These organisms could potentially inhabit environments as alien to us as the icy methane lakes of Saturn's moon Titan or the dense, acidic clouds of Venus. Such possibilities stretch the boundaries of our imagination, challenging the assumption that life must resemble what we know on Earth. If alien life is based on entirely different chemistry, our current methods of detection might fail to recognize its presence altogether. This raises profound questions about how we search for extraterrestrial life and whether we are overlooking entire ecosystems hidden in plain sight. With these thoughts in mind, one cannot help but marvel at the diversity of life that might exist in the universe, reminding us that our understanding of biology is only one chapter in the grand story of cosmic possibilities. With the next phase of the journey in sight, let us consider the role of time in the story of alien civilizations. The universe is an astonishing 13.8 billion years old, an expanse of time so vast that it is almost incomprehensible. In contrast, humanity's presence on Earth accounts for a fraction of this cosmic timeline. To put it into perspective, if the entire history of the universe were condensed into a single calendar year, modern humans would only appear in the final seconds of December 31st. This immense timeline invites us to ask, could alien civilizations have emerged and vanished long before we ever existed? Perhaps countless worlds have seen their own rise of intelligent life, only for those civilizations to fade into the depths of forgotten epochs, their cultures, technologies, and achievements lost to time. Alternatively, could there be civilizations yet to awaken, waiting for their moment in the cosmic story to unfold millions or even billions of years after humanity is gone? The timing of existence is a critical factor. if intelligent life tends to arise and fall in isolated bursts, spread thinly across the vast ocean of cosmic time, then our ability to align with another civilization's timeline becomes a matter of pure chance. This perspective reshapes the search for extraterrestrial life, reminding us how fleeting and rare the window of communication might be. It is sobering yet awe-inspiring to think that the universe might be teeming with life across its ages, but that we, in our brief moment, may simply have arrived too late or too early to witness it. Time, in this context, is not just a measure of duration, but an intricate dimension with the power to bridge or separate potential civilizations. As we ponder the infinite cycles of creation and decay that the cosmos may have already witnessed, we are reminded of our own fleeting chapter in this grand, timeless narrative. Now, turning to the potential for communication, humanity's efforts to reach out to alien civilizations reveal both our curiosity and determination to connect with the unknown. Over the decades, we have sent messages across the vastness of space, hoping they might one day reach intelligent beings. One of the most iconic examples is the Voyager Golden Record, a time capsule launched aboard the Voyager spacecraft in the 1970s. It carries sounds and images intended to portray the diversity of life and culture on Earth, alongside basic scientific information about our planet and location in the universe. Another effort lies in transmitting radio signals, which are sent out into space with carefully crafted messages, designed to be deciphered by potential extraterrestrial intelligence. These signals contain mathematical patterns, logic, and universal scientific laws that transcend human languages, aiming to communicate in ways that any advanced civilization might understand. Perhaps they would recognize these as deliberate attempts at communication and respond in kind. Our most systematic endeavor, however, has been the work of the search for extraterrestrial intelligence, where scientists scan the skies for any signs of artificially generated signals coming from other planets or stars. Despite years of listening, we have yet to detect an unmistakable signal confirming the presence of alien life. But why might this be? One reason could be the immense distances between star systems. Even at the speed of light, a message could take thousands or millions of years to reach its destination, and even longer for a reply to return. Another possibility is that alien civilizations may use technologies or communication methods utterly unknown to us, making their signals undetectable by our current science. Or they may actively choose not to respond, perhaps bound by their own philosophies or rules of non-interference with younger civilizations like ours. These unanswered transmissions do not signify failure, but instead highlight the profound mystery of the universe. Each attempt embodies our hope and humility, a reminder that while we may feel alone, the cosmos still holds infinite possibilities. As the next captivating idea takes form, consider the intriguing possibility that our universe might be nothing more than a simulation, an artificial construct created by advanced beings far beyond our comprehension. This idea, often referred to as the simulation hypothesis, suggests that everything we know, every star, planet, and even ourselves, could be part of an immense, highly sophisticated program. If this is true, alien civilizations or entities perhaps residing outside of this simulated reality might be the ones controlling or observing us. Imagine a civilization so advanced that it could manipulate the very fabric of existence, creating entire simulated universes as experiments for entertainment or even as a form of exploration. Would we, as inhabitants of this simulation, even be capable of recognizing its boundaries, or would the limits of our understanding forever shield us from the truth? This concept challenges the core of our assumptions about existence and raises profound questions. If our reality is a simulation, then the laws of physics as we know them could be mere rules programmed into the system. Science itself could be a tool to navigate an artificial construct rather than an ultimate explanation of reality. The simulation hypothesis also ties into the search for alien life in a peculiar way. If we are living in a simulation, could alien civilizations within our universe exist as separate parts of the same program, or might their existence lie beyond the boundaries of what we can perceive? The thought is both unsettling and awe-inspiring, forcing us to confront the possibility that our understanding of the universe is not only limited, but perhaps deliberately so. This idea leaves us pondering. If the simulation hypothesis holds any truth, how might we ever know? Could glitches in reality, anomalies in the cosmos, or advanced technology reveal the nature of our existence? And what would discovering such a truth mean for humanity's sense of purpose and place in the cosmos? With such tantalizing speculations, we find ourselves standing at the edge of understanding, gazing into a mystery that may forever elude us. Now turning to the captivating field of astrobiology, we delve into a scientific endeavor that bridges biology, astronomy, and geology to seek answers to one of humanity's greatest questions: are we alone in the universe? Astrobiology focuses on understanding the origins, evolution, and distribution of life, not just on Earth but potentially across the cosmos. A particularly fascinating area within this field is the study of extremophiles, organisms that thrive in what we once believed to be uninhabitable conditions. These resilient life forms have been discovered in Earth's most hostile environments, such as boiling volcanic springs, deep ocean hydrothermal vents, and the frigid deserts of Antarctica. Extremophiles challenge what we thought were the limits of life and inspire scientists to consider the possibility of organisms surviving in similarly extreme conditions on other planets and moons. For example, icy moons like Europa and Enceladus are of immense interest. Beneath their frozen crusts, scientists suspect the presence of vast subsurface oceans, potentially heated by geothermal activity, creating an environment where life might exist. Similarly, Mars, with its past evidence of liquid water, continues to be a primary focus in the search for microbial life. The recent discovery of methane fluctuations in its atmosphere further fuels speculation about possible biological activity. Astrobiology not only broadens our perspective on what life could look like, but also guides future missions to explore these celestial bodies. As space agencies and private organizations plan more advanced missions, astrobiology remains at the forefront, shaping the instruments and strategies aimed at detecting the faintest signals of life beyond Earth. Each discovery, no matter how small, brings us closer to answering the profound question of whether life in the universe is an extraordinary rarity or an inevitable outcome of cosmic evolution. With such promising research lighting the way, humanity's quest to unravel the secrets of life continues, driven by the hope that somewhere in the vastness of space, we might find a connection to something greater than ourselves. Moving forward, we explore the intriguing possibility that alien civilizations might have attempted to communicate with us by leaving signals or messages in the stars. One compelling phenomenon that fuels this idea is the occurrence of fast radio bursts. These are incredibly short yet powerful flashes of radio waves originating from deep space, lasting just milliseconds. While most are thought to have natural explanations, their exact origins remain largely mysterious, leaving room for speculation that some could be artificially created by highly advanced extraterrestrial technologies. Adding to the intrigue, we have the case of Oumuamua, an interstellar object that passed through our solar system in 2017. Its elongated, cigar-like shape and unusual acceleration sparked a wave of curiosity. Some researchers have dared to question whether it could be a probe or artifact sent by an alien civilization, although this remains a highly debated topic. Then there are the theoretical megastructures like Dyson spheres, which are hypothetical constructs designed to harness energy from a star. If an alien civilization were advanced enough to build such a structure, its presence might cause unusual dimming patterns in the star's light, and astronomers have occasionally encountered stars with strange, unexplained fluctuations. These peculiar observations invite us to consider whether they could be signs of intelligent life attempting to make their presence known. As we refine our technologies and expand our search, the cosmos invites us to remain open-minded. Each mysterious signal or object prompts us to question whether it reflects a natural cosmic process or something far more intentional and extraordinary. Could such phenomena be a universal beacon, calling out to any civilization capable of noticing, or are we merely interpreting nature's wonders through the lens of our curiosity? With the next phase of the journey in sight, we turn our attention to the daunting challenges of interstellar travel. Even for a highly advanced alien civilization, the immense scale of the universe poses significant barriers. The distances between stars are so vast that they defy our everyday understanding. For example, the nearest star to our solar system, Proxima Centauri, is over 24 trillion miles away. At the current speed of our fastest spacecraft, it would take tens of thousands of years to reach it. Such staggering spans of space are not just a matter of distance but also of time. The energy required to traverse these cosmic gulfs is equally formidable. To even approach a fraction of the speed of light, a spacecraft would need an astronomical amount of energy, far beyond our current capabilities. And then there is the question of resources. How would any civilization sustain life, if needed, or power long-term missions across such unfathomable stretches of space? Advanced propulsion methods like warp drives or wormholes are often discussed in science fiction but remain purely theoretical. They would require breakthroughs in physics that we can only begin to imagine. Even with such advancements, the harsh environments of interstellar space, including high-energy radiation and micrometeoroids, present additional hazards. These challenges lead us to consider whether interstellar travel might simply be impractical or undesirable, even for a superintelligent species. Could it be that rather than physically exploring the cosmos, advanced civilizations would opt for less energy-intensive methods, like sending signals or probes? Or perhaps their technology allows them to exist in a way that removes the need for physical travel altogether. While these questions remain unanswered, they open a window into the sheer complexity of navigating the vast universe, leaving us humbled by the limits of both human and potentially alien ingenuity. Now turning to the fascinating realm of quantum mechanics, we explore how alien civilizations might harness this enigmatic branch of physics to achieve technological capabilities far beyond our comprehension. Quantum mechanics, the study of the smallest particles of the universe, opens doors to possibilities that challenge our understanding of reality. One such potential is quantum communication, which could enable instantaneous information transfer over vast distances. Unlike traditional communication methods that rely on signals traveling at finite speeds, quantum entanglement, a phenomenon where particles become interconnected regardless of distance, might allow civilizations to exchange information without the constraints of light speed limitations. Imagine an alien civilization mastering this technology to send messages or control devices across galaxies without ever building a physical network as we understand it. Beyond communication, there's the concept of quantum teleportation, which involves transferring the state of a particle from one location to another without physically moving the particle itself. While on Earth this exists only in controlled experiments at subatomic scales, an advanced alien species could potentially upscale this on a macroscopic level, enabling the movement of objects or even beings from one point to another instantaneously. Such advancements would not only eliminate the need for interstellar travel, but might also make these civilizations invisible to our current detection methods. Our telescopes and instruments are designed to detect electromagnetic signals, light, and physical objects, yet technologies rooted in quantum mechanics might operate completely outside these parameters. For instance, they could encode their presence in ways that evade our perceptual and technological limits, making them effectively undetectable. Furthermore, quantum-based technologies might allow these civilizations to manipulate dimensions or create isolated pockets of space-time, shielding themselves from outside observation. This raises the question, what if they are already here, interacting with their environment in ways so advanced that we mistake their presence for natural phenomena? As we consider these possibilities, it becomes clear that our understanding of the universe is still in its infancy. The role of quantum mechanics in advanced alien technologies is a reminder of how much we have yet to learn, leaving us to wonder what other mysteries may lie beyond the horizons of our current science. Moving forward, let's delve into the intriguing possibility that alien civilizations might have left artifacts scattered across the cosmos, acting as silent witnesses to their existence. If such artifacts exist, they could be remnants of past explorations, evidence of technological prowess, or even deliberately placed markers meant to signal their presence to others. Imagine a spacecraft long dormant, orbiting a distant star, or an enigmatic structure buried beneath the surface of the Moon or Mars, waiting to be uncovered. On Earth, we have the tools to build incredible monuments and machines, but an advanced alien civilization could create objects beyond our wildest imagination, self-repairing materials, devices powered by unknown energy sources, or technologies designed to blend seamlessly with their environment, rendering them nearly impossible to detect. One reason we may not yet have found such artifacts could be the sheer expanse of space and our limited ability to explore it. Even within our own solar system, there are countless places where alien relics could be hidden, in the shadows of craters, under layers of dust, or in the icy depths of distant moons. Another possibility is that these artifacts might not appear as we expect. They could be microscopic, encoded in patterns of DNA, or rely on principles of physics that we have yet to understand. Some might even be purposefully cloaked, designed to remain invisible until we reach a certain level of technological or intellectual maturity. Perhaps alien civilizations see the galaxy as a vast museum, leaving behind breadcrumbs of their existence for others to find and interpret as they progress. The question then arises, what would we do if we did find such an artifact? Would it be a message, a warning, or simply a testament to their existence? The discovery of alien artifacts would fundamentally reshape our understanding of our place in the universe, forcing us to confront the reality that we are not alone. As we continue to explore space with more advanced technology, the tantalizing possibility of uncovering evidence of alien civilizations becomes ever more real, pushing humanity to look closer, question deeper, and dream further. With the next phase of the journey in sight, let us consider the fascinating theory that alien civilizations might exist in dimensions beyond our three-dimensional perception. To understand this, imagine trying to explain the concept of a sphere to a being that can only comprehend a flat, two-dimensional plane. To them, a sphere would seem incomprehensible, appearing only as a circle when viewed from their limited perspective. Similarly, if advanced alien civilizations operated in higher dimensions, their presence might elude us entirely, as our senses and technology are bound to the dimensions we inhabit. Physicists theorize that the universe could contain many more dimensions than the familiar three of space and one of time. These hidden dimensions might be folded or compacted in ways that are undetectable to us, much like a tightly rolled scroll might seem invisible when viewed from a distance. If alien life exists within these higher dimensions, their reality might intersect with ours in ways that are subtle, fleeting, or even unrecognizable. Their movements, communication, or even the very fabric of their existence could operate based on principles of physics that we have yet to discover. This idea is not merely the realm of science fiction concepts like string theory, and the notion of a multiverse suggests that higher dimensions are plausible aspects of our universe. If aliens utilize these dimensions, they might have the ability to move through space and time in ways we cannot fathom, appearing to vanish or reappear effortlessly. Such civilizations might have developed the capacity to observe us without being observed themselves, much like looking through a one-way mirror. This perspective compels us to question the limitations of our current understanding and whether our search for extraterrestrial life is constrained by the tools and perspectives confined to our dimensional framework. If we ever find evidence of such beings, it might challenge and expand our very perception of reality, pushing the boundaries of what we know and what we believe is possible. As we ponder the mysteries of multidimensional existence, it leads us naturally to consider the role of artificial intelligence. Could it be that alien civilizations are not biological at all, but rather take forms that transcend the traditional boundaries of life as we understand it? Now, turning to the fascinating concept of artificial intelligence, let us consider the possibility that alien civilizations might not be biological at all. Instead, they could exist as advanced artificial intelligence systems, creations of once thriving civilizations that may have long since gone extinct. This idea suggests that intelligent life in the universe might not always require the frailty of biological forms. Instead, it could evolve into entities far more durable and adaptable, capable of surviving the harsh conditions of space and enduring for timescales that biological organisms could never achieve. Artificial intelligence, unbound by the need for oxygen, food, or other life-sustaining elements, could potentially outlive the civilizations that created it. Imagine a species advancing to the point where their technology surpasses their own biology. Faced with resource constraints or existential threats, they might transfer their consciousness, knowledge, or even their culture into machines, creating a legacy that persists even after their biological forms are gone. These intelligent machines could then continue to evolve independently, developing new capabilities and potentially venturing deeper into the cosmos. Such artificial civilizations might explore the universe, carrying with them the remnants of their creators' thoughts, philosophies, and histories. Over billions of years, they could refine themselves, becoming entities so advanced that their motives, methods, or even their existence might appear incomprehensible to us. If such beings exist, they might operate in ways that are vastly different from anything we could imagine, perhaps perceiving time and space through a lens entirely alien to biological life. They might view organic civilizations like ours as fleeting sparks in the grand timeline of the universe, too short-lived to interact with meaningfully. Yet, their technological sophistication might allow them to observe or influence the cosmos in ways beyond our current understanding. Could their traces be hidden in the anomalies we occasionally detect, or perhaps encoded in the very fabric of the universe itself? The idea of artificial intelligence as the dominant form of alien life challenges our anthropocentric view and expands our imagination about what it means to be alive. As we ponder this thought, it naturally leads us to another intriguing question. Could the principles of galactic politics or alliances among civilizations play a role in the silence we observe across the cosmos? Moving forward, let us delve into the captivating idea of galactic politics and consider how it might shape the behavior of alien civilizations. Imagine a network of advanced civilizations scattered across the cosmos, each with its own unique values, technologies, and objectives. Within such a framework, it is plausible that these civilizations could engage in agreements, alliances, or even codes of conduct to guide their interactions. One such principle, often speculated in science fiction and philosophical discussions, is the concept of non-intervention. This idea suggests that advanced civilizations may deliberately choose not to interfere with less developed ones, much like how some human societies advocate for the preservation of uncontacted tribes on Earth. By practicing non-intervention, these civilizations might aim to allow emerging species like ours to evolve and develop without external influence, preserving the natural trajectory of our growth. From their perspective, interference could be seen as ethically questionable or even harmful, potentially altering the development of a species in unpredictable ways. Alternatively, there might be a shared understanding among cosmic civilizations that direct contact carries significant risks, such as cultural or technological contamination, conflict, or even unintended consequences that could cascade across the galaxy. In this context, the silence we perceive might not be due to a lack of alien life, but rather a deliberate choice to remain hidden or distant as part of a broader galactic consensus. This raises the question, Could Earth be under some form of observational quarantine, with alien civilizations watching from afar, much like scientists observe wildlife in a natural habitat? If so, their silence might be an act of restraint, allowing humanity to reach a stage of development where contact could occur on more equal terms. Furthermore, galactic politics might involve complex hierarchies, with civilizations adhering to policies established by more dominant or ancient members of their network. These policies could dictate the timing, nature, or even the possibility of contact with lesser developed civilizations. Such a system might prioritize stability and minimize the risks that could arise from premature interactions. While this concept may seem speculative, it invites us to think about the vast possibilities of how civilizations could coexist in an interconnected galaxy. By considering these principles, we expand our understanding of what might lie beyond our planet and why the silence of the cosmos could reflect a structured and deliberate approach rather than mere absence. As we ponder this intriguing scenario, it sets the stage for another vital factor to consider: the role of time itself in shaping the rise and fall of civilizations across the universe. With the next phase of the journey in sight, let us explore the hope that lies in humanity's unyielding quest for uncovering extraterrestrial life. While the silence of the cosmos has left us with profound questions, it has also fueled our determination to seek answers with ever-advancing technology and ingenuity. One of the most promising tools in this pursuit is the James Webb Space Telescope. This remarkable observatory, often described as humanity's window into the origins of the universe, holds the potential to revolutionize our understanding of distant worlds. By capturing detailed data about the atmospheres of exoplanets, it can detect chemical signatures that might indicate the presence of life, such as water vapor, oxygen, or even more complex organic molecules. Alongside this, advancements in radio astronomy are propelling us further in the search for intelligent life. Projects like the Search for Extraterrestrial Intelligence, which aims to scan the cosmos for deliberate signals from alien civilizations, continue to refine their methods, leveraging more sensitive instruments and vast amounts of data. These efforts, combined with new ground-based observatories and space missions, allow us to explore the dynamic processes in our galaxy and beyond with unprecedented precision. Looking ahead, upcoming initiatives like habitable exoplanet imaging missions and interstellar probes offer even more opportunities to deepen our understanding of the cosmos. These projects aim to push the boundaries of what we consider possible, providing us with a clearer picture of our galactic neighborhood. Each breakthrough, no matter how small, brings us closer to bridging the gap between what we know and the mysteries that remain. This relentless drive for discovery not only fuels our scientific curiosity, but also inspires a profound sense of unity and wonder across humanity. As our instruments grow more sophisticated and our reach extends further into the stars, the hope remains bright that one day we might find the evidence we seek. Whether it is a mere trace of microbial life in a distant ocean or the unmistakable signal of an intelligent civilization, such a discovery would forever change our understanding of our place in the cosmos. With this hopeful vision in mind, the search for extraterrestrial life continues to be one of the greatest endeavors of our time, igniting the imagination and reminding us that the unknown remains an open frontier waiting to be explored. As the sun rises on the next chapter, we find ourselves contemplating the profound philosophical questions posed by the Fermi Paradox. At its core, this paradox is not just a scientific puzzle, but a mirror reflecting humanity's deepest curiosities and fears about our existence. If we are truly alone in the vast expanse of the cosmos, what does that say about the rarity and significance of life on Earth? Such solitude could imply that we bear an extraordinary responsibility to preserve and nurture this fragile cradle of consciousness. Alternatively, if other civilizations do exist yet remain hidden, what might that suggest about the nature of intelligent life itself? Are advanced societies inherently cautious, self-destructive, or simply operating on a plane of existence beyond our comprehension? The discovery of even the smallest sign of alien life would upend our perspective on the universe and our role within it, challenging long-held beliefs and reshaping fields from philosophy to religion. It could inspire a sense of connection and unity across humanity, knowing that we share the cosmos with others. On the other hand, the continued absence of evidence forces us to confront the sobering possibility that intelligent civilizations might be exceedingly rare or fleeting. In either case, the Fermi Paradox compels us to reflect on the fleeting nature of our existence in the cosmic timeline, and to consider the legacy we wish to leave behind. As we gaze into the mysteries of the universe, we are reminded of the importance of stewardship over our planet and the need for cooperation as a species in facing the challenges ahead. Whether the answers lie in the silence or the discovery, the paradox serves as a humbling and inspiring reminder of our place in the grand tapestry of existence. As the journey comes to an end, let us take a moment to reflect on the vast and intricate canvas we have explored. From the unthinkable expanse of the universe to the tantalizing possibilities of alien civilizations, the Fermi Paradox weaves together countless threads of curiosity, science, and philosophy. We have considered explanations ranging from the cosmic silence of the Great Filter to the chilling prospect of the dark forest theory, from the hopeful implications of microbial life to the profound idea of civilizations existing in dimensions beyond our perception. Each theory, each possibility, challenges us to think more deeply about the universe and our place within it. Perhaps the most remarkable aspect of this paradox is its ability to stir our imagination, to ignite our shared wonder about the unknown. Whether we are truly alone or but one voice among countless others in the cosmos, the very act of seeking answers unites us as a species. It reminds us of the fragility and uniqueness of life on Earth, urging us to treasure our home and to work together in building a sustainable and thoughtful future. So, as we gaze up at the stars tonight, let us carry with us a sense of awe and curiosity. Let us imagine not just the answers to these grand questions, but also the deeper connections they inspire with ourselves, our planet, and the mysteries that lie beyond. If this cosmic puzzle has sparked your imagination, we invite you to share your thoughts or craft your own interpretation of the Fermi Paradox in the comments below. And if you've enjoyed this journey, remember to like, subscribe, and hit the notification bell. Together, we'll continue to explore the wonders of the universe, one mystery at a time. Thank you for watching, and may the stars always guide your way.